Welcome to our pre-calculus lesson 9 video. In this video, we'll discuss adding, subtracting, multiplying, and dividing functions. And another thing we'll do, which is a recap from our practice maths, which is like we have given some practice maths previously. We'll try to revise them, and we thought that is also important for this lesson. So let's begin. The other thing, practice solutions. Then we have some optional practice. You can see operations with these symbols, they are operators. Then review of some algebraic rules which will be needed for the next thing, for the combined functions. We'll try to combine some function, and then some practice maths for the class. So let's start. Look at this maths, 21 number, 24 number. What is the domain and range of this math? This is the practice maths actually from the book. You will see this maths in page 57, question number 21, 24, then 41, 57, and 58. These are from our PDF book, so you can just easily, if you want, you can go there and see. So this 21 number, what is the domain and range of this 21 number? Since you know the domain are the x value, this is the domain, this is the domain, this is the domain, this is the domain. They are the domain. So domains are 1, 2, 3, 4. What are the range? Range is 3, 3, 3, 3. In this case, all the ranges are same. By the way, is it a function? Is it a function? I mean, it looks like all are 3 in the y. So is it a function? Answer is, this is a function, because the definition of function is for each x value, there must be one y value. For example, for 1, there is only one answer, and that is 3. It's not like for 1 there is another answer, suppose 2. Suppose if I write here without giving bracket, suppose if I write here 1 comma 5, let's say 1 comma 5. Now this is not a function. Now this line is not a function, because one time for 1 it is 3, another time for 1 it is 5, then it is not a function. But now it is a function. Now it is a function. I think 24 number now you can solve. Which is it? What is the domain and range of this function? By the way, 24, is it a function? What do you think? 24 is a function or no? Look at this one and this one, then you will understand. That's the clue. 24 number. I think you will say that this is not a function, because for minus 4 we have 0, we have 4, and for minus 4 we have 0. So this is not a function. How can we find out the domain of this function for this 57 number? How can we find out the domain from here? For finding the domain from this kind of algebraic thing, where there is something numerator, something denominator, we have to look for which our function becomes undefined. For what value of x, to be more specific, for what value of x our function becomes undefined. Let me give you one example. Suppose if I write 1 divided by x, you know that 1 divided by 0 is undefined. This means undefined. This is one thing. And another thing is square root of negative anything is undefined. These two things is undefined. 1 divided by 0, 1 divided by 0 is undefined. Then square root of negative thing is undefined. Okay. So 1 divided by x, for what value of x this will become undefined? If x equals to 0, right? If x equal to 0, then 1 divided by 0 it becomes undefined. If x equal to 1, then no problem, 1 divided by 1 equal to 1. If x equals to 2, then no problem, 1 divided by 2 equal to 0.5. What I mean by this is, let me repeat it once again. This kind of thing is not defined in math. If you try to do it in the calculator, calculator will tell you this is math error. 1 divided by 0, math error. 1 divided by 0. See, 1 divided by 0. Okay, if I give equal to, then it will say math error. See, math error. So 1 divided by 0 means math error. Then square root of minus 1 is square root of minus 1. See, square root of minus 1 equal to math error. These are undefined in mathematics. So that's why we cannot go there. Now see, that means this value here needs to be, it cannot be 0 and it cannot be negative, because it is within square root. So we have two conditions. It is denominator, for denominator one condition. For denominator condition is it cannot be 0. Number 1. Number 2, there is a square root. So we have another condition. It has to be more than 0. More than 0 means it has to be positive. Any number greater than 0 means positive. That means this x minus 9, this value has to be x minus 9. This has to be greater than 0. This value has to be greater than 0. That means x, if I send the 9, if I add 9 in the both sides, then it will become x is greater than 9 goes to the other side. You can think this way also. This is the domain of this function. This is the domain of this function. This is the domain of this function. I'm looking for my mouse pad. This mouse pad. Sorry. I got it. So this is x. So you got it, right? And so this one will be what? X minus 4 e. This has to be greater than 0. So it will be x is greater than 4. X is greater than 4. We can say. So these are the domain. These are the domain of this function. These are the domain of this function. Let me show you, if there is no square root, then what is the answer? Okay. Let me show you, if there is no square root, then what is the answer? Suppose this function is 4 divided by x minus, let me write something new, so that it do not makes you confused. X minus 3. If there is no square root, then this function will be x minus 3. This cannot be equal to 0. This cannot be equal to 0. But it can be anything else. So this is not equal to 0. So x is not equal to 3 goes to the other side, so it becomes plus 3. So the domain of this is x cannot be equal to 3. That means all real number other than plus 3. Because if it is plus 3, what happens? 3 minus 3 equal to 0, right? 3 minus 3 equal to 0. 4 divided by 0 means undefined. That means at x equal to 3, this function becomes undefined. So what is the domain of this function? All real number other than plus 3. So what is the difference between this one and this one? There is a square root, there is no square root. If there is a square root, then we have to bring only the positive number. Positive number, again it cannot be 0. That means more than 0. See, it means more than 0. X minus 9, this quantity here has to be more than 0. So what we said here, what is the meaning? Now I am trying to discuss it. What is the meaning of this? The meaning of this is x, the value of x has to be more than 9. Then there will be some answer of this function. So more than 9 means what? 9.1, 9.2, 9.5, 10, 11, 13, 14. If you put here 10, what is the answer? 10 minus 9 equal to 1. Root 1 equal to 1, 4 divided by 1 equal to 1. We have some answer. Do you understand? But what if x value is less than 9, suppose x value is 8, what happens? 8 minus 9 equal to minus 1, square root of minus 1 equal to negative. That means undefined. If the value of x is less than or equal to 9, then it becomes undefined. That's why it has to be more than 9 when there is a square root. So the condition for square root is within the square root that value has to be greater than 0. That means it has to be positive, some positive number. It has to be some positive number. Let me show you one more example from these sections to give you all the concept how to find out the domain. Just one thing remaining. Suppose you have same type of one function within a square root. Suppose a square root of some function f of x equals to suppose x minus 2. Then how can you do? We gave here greater than, and what will be this? There is no, this is just the numerator. It is not in the down now, it is up. Now what will be the domain? Now the domain will be this x minus 2 has to be greater than or equal to 0. Now it can be equal to 0 because it is not a denominator anymore. It is not a denominator, it is numerator. It is a normal regular expression. It is not in the downside. That's why you can give equal to now. That means this value can be 0 now because square root of 0 equal to 0. So you have answer 0. 0 is also answer. But 1 divided by 0 is undefined. It cannot, downside number cannot be 0. So in this case the domain for this thing will be x is greater or equal to 2. So domain of this function, if I write f of x equals to this, so domain of this function is this. In fact, these are the types of all the maths here which are related to find the domains. These rules are actually enough for solving all the math. Mostly these are the condition, and if the math is something like some other things like find out the domain of f of x equals to let's say twice x plus 1. What is the domain? These are the simplest things, very simple thing. Actually domain of this function is all real number, because there is no square root and there is no this is not a denominator position. This thing, there is no denominator, there is no square root. So for x you can put anything that you like, any value you want you can put here. That means that's why the domain of this function is all real number. There are tons and tons of function actually where the domain is all real number. Suppose fx equals to x plus 2, twice x plus 1, twice x, fx equal to just only x, fx equals to, there are like x cube plus x, x square minus x, any regular but simple kind of straight line, quadratic, this kind of thing where there is no square root or denominator. Everywhere if you see there is some x involved, you can put actually any number you want. You can put any number you want. Of course you have to be a little bit careful also while you put. You have to look at the functions just to be more sure, more clear. So that's all about the function, how to find out the domain. We have actually the answer. See, 21 number, it is a function, domain of this, range is this, 21 it is not a function because there is a problem. 57 number, so this is the domain, x has to be greater than 9, this x has to be greater than 4, 58 number. This math is 41 number from the book, fx equal to x divided by x square plus 1. So if x equal to 0, if x equal to 0, what is the value of this function? That means for all the x you have to put 0. So 0 here and x equal to 0, that means 0 square equal to 0, 1 plus 0 equal to 1, 0 divided by 1 equal to 0. You have to keep this in mind. 0 divided by any number equal to 0. But any number divided by 0 equals to undefined equals to undefined. Undefined. Now you can say, sir, you have written here 1. Why you are saying it any number? That means you can put any number here. This is what I meant by that. Okay, you can put any number. So 0 divided by 1 equal to 0. Then if you put minus 1, this is the answer. If you put x plus 1, that means for instead of x, now you have to put x plus 1. So there is a x here, so you have to put x plus 1 there. There is a x here, then square, so you have to put x plus 1, then square. And x plus 1 is square equal to, if you use the formula, a plus b whole square formula, a plus b whole square formula is, you can multiply also. A plus b whole square formula is a square plus twice ab plus b square. A square plus 2ab plus b square. You can use this formula to find out the expression, and there is then plus 1. And plus 1 plus 1 equal to 2. So this way. This is like x equal to twice x, so just put it here, then individually you have to square. 2 square equal to 4, x square equal to x square. This is also review. Still you should do all this kind of math. Actually you should practice this kind of math. Then this is a real life application math, and this type of maths are important, by the way, because they actually connect our concept and real life situations. So please always practice this kind of math. Always look at this kind of math. Fortunately, in this math, in most of the real life application math, the function usually they give, we have to just work on the calculation and understanding part in most of the cases. So if a rock falls from a height of this, the function is given h of x equals to 20. X is the time, x seconds approximately. So x is the time, h is the height. So h of x equals to 20 minus 13x squared. This is the given function. We do not write this function. The function is directly given to us. Now we have to work with this function. If you open the book, you will see that for this question, you will see that math number is not written here, right? So you can say, sir, which number math is this? Let me show you which number math is this. Let me show you which number math is this. This one, effect of gravity on Jupiter, this math. Okay, let me discuss this math from here. It will make more sense because we have the full question here. So this is the question. They said, what is the height of the rock when x equal to 1? That means you have to put 1, then do some calculation. Then another time x equal to this, then 1.2 you have to put here. Then we have to do this calculation. Then the question is, when is the height of the rock is 15 meter? When it is 10 meter? When it is 5 meter? Now the question is when. Now the question is when. When means find out x, find out time. Time is what in this question? So they are asking now, what is the time? That means now this 15 meter, this is the height. So here in this case you have to put 15 meter here. We have to put 15 meter here now. Then when it is 10 meter, that means we have to put here, then find out x. When it is 5 meter, we have to put 5 here, then here. Next question, when does the rock strike the ground? Strike the ground means height is 0. That means in this case, we have to put 0 here and do the calculation to find out the value of x. And the calculation is done in our slide also. We roughly have done the calculation. So this is the calculation. As you can, h of 1 equal to this, h of this, and then if 15, h of x equals to 15. So if you put 15 here, x equals to what? X equals to this. And what is the value of h of x in the ground? That means this side is 0. And if you set 0, this is how you solve it and you get the solution on this. All right, I think, yeah, in the slide you cannot see that. Where it goes, somewhere in the setting, okay. Let's discuss it from here. Identify the function versus non-function. Which one is function, which one is non-function? These are the more optional practice math. Then this is -2, -1, 0, 1, 2. So you see the initial, everywhere x values are different, so this is a function. But here, see, is it a function? This is not a function, right? Because they are not, for one time answer is 1, for 1 another time answer is -1, so this is not a function. This one is not a function. Then find f of 2, g of f of -4. That means instead of x you have to put this value and do some calculation. The f of x function is this one, g of x function is this one, and this is some function. This kind of math actually we have here also. This one is also similar kind of math. We just have to put x value and just do the calculation for that. Identify the domain of the function. Now this one actually looks like the math that we try to solve back, and by using the rule that we have discussed, actually we can find out the domain from here. This is x squared plus 3x, which is downside, and we said that this downside, this number, this denominator cannot be 0. So that means x squared plus 3x for this first math, this cannot be equals to 0. And if you take x common, so it becomes x plus 3 cannot be equals to 0. That means from here you have two answers. One is x cannot be equal to 0 directly, x cannot be equals to 0, then comma, this is x plus 3 equal to 0, x plus 3 equal to 0. That means x cannot be equals to -3. This is x plus 3 cannot be equal to 0. So 3 goes to the other side, then it becomes x cannot be equals to -3. So we have this. This is the domain. The domain for this function is all real number, but x cannot be 0, x cannot be -3 for this function. And this one is what now? This one actually exactly fits within the definition that we discussed. This one fits within the definition that discussion that we have done just a while back. So this 2 minus x, this has to be greater than, since it is within the square root, it has to be greater than 0. So we can do it in two ways. One is minus x is greater than 2 goes to the other side, then sign changes, or you can add both side -2, that is also fine. Now to remove minus sign from the both side, we have to change the direction of this sign also, the symbol also. So it will be like x is less than 2, x is less than 2, x is less than 2. That means for this function, domain is all real number which is less than 2. Yeah. So this will be the domain. This will be the domain of this one. X has to be less than 2 for this function. Mathematical operations with this kind of, these are actually a little bit easier thing, like suppose we have given, suppose a function is given as fx equals to twice x plus 8, then another function is given gx equal to 4x. So if I say this is gx equal to 4x, so if I say gx plus 2 equal to what? So what does it mean? It means actually 4x plus 2 equal to what? Right? Because gx equal to 4x. So it means 4x plus, because g of x means 4x. So we can write, for g of x we can write 4x, then plus 2. This kind of thing here actually. So here we said fx minus 5 equal to what? That means fx means this. Fx means this. Then fx minus 5. That means this value minus 5. So this minus 5. See? This is the fx. This is the fx. Minus 5. So 8 minus 5 equal to 3. Finally we get x, twice x plus 3. Then gx divided by 2. Gx divided by 2 means this is 4x, 4x divided by 2. That means if you see fx, gx, we have to put their function equivalence. Like this is the notation and this is the content that function have. So this function has this content. This is the thing that this function has. This is the notation. This is the notation of that function. All of them will have the similar kind of operation. Suppose it is g of x f of x divided by g of x. What does it mean? So it means f of x, first we have to write f of x, which is twice x plus 8, then divided by g of x, that means divided by 4x, like this. Now you can look at, can we do any more calculation from here? If we can do any more calculation, you can do. If we cannot do any more calculation, you can just leave it as it is. If you want, you can do some just one little calculation from this. Then it becomes 8 divided by 4x. Then actually we can do some cancellation here and here. So 2 and 4 cancel out, 2 remaining, x and x cancel out. Then 4 and 8, this cancel out, and 2 is remaining here. So it is, this term is, the remaining term is 2 divided by x here, and this is 1 by 2. So that means from here it is, this term is, the remaining term is 1 divided by 2, then plus 2 divided by x, plus 2 divided by x, plus 2 divided by x, plus 2 divided by x. Okay. So this kind of thing. We have done actually all of them here. You may have a look. So this kind of thing. 1 divided by 2 plus 2 divided by x, the one that we discussed. So how can we work with the fraction? Some students actually make these mistakes. Some students actually have this problem. This is the rule. When you have some fraction, then we have to do LCM in the downside. And then we can actually, this becomes AD and this becomes BC. Just, this is another way to do it. Let me show you with the example here. This method is like, how can we make the same denominator so that we can take the denominator common? Okay, so this method is like that. And this one, suppose, how can we simplify it? 1 by 4 plus 2 by 3. So how can we simplify it? So there is nothing common between 4 and 3. 3 is a prime number. 4 is composite, but there is no common thing in between them. So we can just multiply them. 3 into 4 equals to 12. And that is their LCM. 4 divided by 12 equal to 3. And 3 into 1 equal to 3. Then plus 3 divided by 12 equals to 4. 4 into 2 equals to 8. So it will be 12. So 3 plus 8 equals to 11. And for minus, that means for minus there will be minus in between. That sign will be minus, that sign will be negative for minus. Let me show you quickly if you have question. So 5 and 7, there is nothing common here. Let me write it, 2 divided by 5. This is quite silly things, quite very simple thing for our level. but if someone have this problem, then they need to rectify it, or else they will make mistake in every math. If anyone do not know this kind of thing in our level, then they will make mistake in almost every math. That's true. That's true. Because these are like very elementary level thing. Anyway, so this is x divided by 7. So 5 and 7, there is nothing common, so we need to multiply them. 5 and 7, if you multiply, what is the answer? 5 sevens are 35. Then see, 35 divided by 5 equals to 7. 7 into 2 equals to 14. Then we will give this minus. 7 divided by 35 equals to 5. 5 into x equals to 5x. Now in this math, we cannot do anything else, because 14 minus 5x, we cannot do them. We cannot simplify it. Now this one, let me show you this one. 1 divided by 4 divided by 2 divided by 3. Now, one thing that we can do for division to simplify our math, we can transform this thing from division to multiplication, and if we do that, then 3 and 2, they will interchange their position. The numerator will become denominator, or denominator will become numerator. This is actually 1 divided by thing, and that 1 divided by thing actually interchanges. So if you just change the division sign to multiply, then you can just interchange all the numerators to their denominator position, denominator to their numerator position. Then we have 1 by 4 into 3 by 2. That means 1 into 3 equal to 3. 4 into 2 equals to 8. 4 into 2 equals to 8. So this way we can we have some simplified form of them. This one also you can do same way. You can just convert it to multiply. Then 7 is downside, so 7 will come here. X is upside, so x will go downside. Then the down you can multiply, up you can multiply. Just like this one. Just like this one. Working with the parenthesis. What is parenthesis? What is parenthesis? Parenthesis is another name of bracket. Another name of bracket is parenthesis. So if you have a into b plus c, we have to multiply a and b, we have to multiply a and c. That means ab plus ac will come here. So suppose if you have, let's say, c plus d, c plus 2d, it will be what? We have to multiply this one and this one. That means it will become 2c plus 2 into 2 equal to 4. Then it will become 4d. There is a method of multiplication with the bracket, with the parenthesis. This is called FOIL method of multiplication. FOIL means this, you can see F O I L. F means first. That means you have to multiply this first alphabet or first quantity with the first quantity. There is two bracket, AD plus BC. First one and first one you will multiply. Then you will write, see, A into B equal to AB. This AB. First one and first one. And then outer. Outer means this one and this one. This is the outer side. This is the outer side. This one is inner side. D and B is the inner side. Inside. D and B, they are inside. A and C, they are outer side. In a building, outside is, if you go from other way around, then you see outside. Outside. So outside number is A, outside number is C. So AC, outer. Then inner. I means inner. Inner means, see, these two is the inner. BD, they are inner. This is last. Last means last of this one and last of this one. First quantity, last one, second quantity, last one. Last and last, we multiply them, then we get it. So this is called the FOIL method. FOIL method means this. Let me show you with an example. So say 2 plus x into, let's say, y plus 3. So first is what? First means this one. They are first of, this is the 2 is the first of first quantity, 3 is this y is the first of second quantity. So it will become 2 into y equals to 2y. Then outer means this is the outer and this is the outer, both sides. So it will be 2 into 3 equal to 6. Why I am giving plus sign here? Because this is a plus and there is a plus before this 2, plus into plus equal to plus. In fact, all will be plus here since there is no negative sign here. So outer gone. Then inner means this inside and inside, which is x and y. That means xy. So it will become xy. Then we have last. Last means this one and this one. So that means x and 3, which is x3 or 3x. Hey, do you think this will be a mistake if we write x3? 3x instead of 3x if we write x3. Is it a mistake? It's not a mistake. It's not a mistake, but it looks a little bit funny. It looks a little bit funny. It's like you have a wallet and you don't keep your money in the wallet, you keep it in this pocket, but you have your wallet down there. It's like that, okay? But it's fine, you know. If you need money, you can give from here. So basically, this is also correct, but it looks funny because 3x means there is x, how many? X plus x, then you get 3x. But this also means the same thing. Anyway, this is not a mistake, but it looks a little bit funny. Not conventional, just to simply say. So FOIL method is actually we use for multiplication, and you may have, now you can say, sir, if I don't follow this FOIL method of multiplication, I already know some method of multiplication. Is that okay? Yes, of course it is okay, as long as you get the correct answer. Suppose if you multiply this one and this one in your method and still you get this answer, then it is correct. Then you are correct. You are allowed to use your method, no problem. Oh, these are the, yeah, so you can just try multiplying them. So if you multiply this 4 into, you can actually add also, because 7 plus 3 equals to 10, 10 into 4 equals to 40, so answer will come 40. And you can do it separately, 4 into 7, then 4 into 3, then add them, then answer will come also same. Now let's work with a combined function. There is two functions given here. One is fx equals to square root of 2 minus x. Another function is g of x equals to x squared plus 1 divided by x plus 3 into x minus 1. How do we combine them? Well, you know, just a while back we discussed we actually can do like f of x plus g of x we can write, f of x into g of x we can write, f of x divided by g of x we can write, or even g of x divided by f of x also we can write. We can actually play with them, kind of. We can actually play with them. So all of these things we can do, as long as you can see all of them are just like some algebraic thing, so we can just work with them. Now our question is actually there is some interesting thing in the question. Let's look at individually what is the domain of this. So you see this square root of 2 minus x, it is not in the denominator. So only if 2 minus x, let me show you how we get this domain. I think many of you Many of you now can easily find out the domain of this kind of thing. So let me show you, just to make sure. So this value 2 minus x has to be greater than or equal to 0. Why it has to be greater than or equal to 0? Because if it is less than 0, then this value is negative. Less than 0, any value means it is negative value. Less than 0, this is 0. In the number line, this is 0. This is 1, 2, 3. This is minus 1, minus 2, minus 3. This is minus, let's say minus 0.5. That means less than 0, anything means these are negative. And negative of square root means undefined. That's why this value 2 minus x has to be positive, or it can be 0 also. Why it can be 0? Because this number is not denominator. If it is in the denominator downside, then it cannot be 0 also. So if we do the calculation, actually we have done this earlier. So we can send this 2 to the other side. Let me send this. So it will become minus x. We can send this 2, send it to the other side. So like this. Then minus cancel out from the both side. But if you cancel out minus from this kind of math, you have to just change this sign. Alternate this symbol. So this is like this. This will become like this, and you can see they are same. Why this symbol changed? Because when you in any inequality math, if you multiply both sides by a negative sign, then you have to alternate this sign. If you multiply by a negative sign in the both sides, then you have to alternate this sign. If it is greater, you have to make it less. Also, if without multiplying, if you think, okay, I am not multiplying, I am just removing minus from here and minus from here from the both side, so I am not multiplying anything. Basically, actually, you are multiplying at that time. At that time also, you have to interchange it. If you remove minus from this side and minus from this side, how can you remove if you do not multiply by another minus? When you multiply this one with a minus and this one with a minus, so minus it becomes plus. Minus it becomes plus. We cannot all of a sudden say, okay, this is gone and this is gone to where? Somewhere in the Pacific Ocean. So this is not some way by which they just leaves. When we remove some minus sign from both sides, basically we are multiplying by another minus sign. When you do that, you have to interchange the sign. And let me show you why. Why exactly you have to interchange the sign. Okay, get ready. If I write two numbers, this is not related to this topic. Just to give you concept, I am discussing this. Suppose if I write minus 2 and 5, these two numbers. Which is bigger here? Which number is big? 5 is big, right? This is minus. So we will say, okay, 5 is big. Right? 5 is big, that's why the sign is minus 2 is less than 5, or we can say 5 is bigger than minus 2. Now multiply both sides by negative, then this will become positive, and suppose now let's keep it same and let's give a minus this side. Now is this correct? If we don't change it after multiplying both sides by negative, is this correct? Now it is saying minus 5 is bigger than plus 2. Is this correct? This is not correct. This is why when you multiply by a negative sign in the both sides for an inequality math, actually you have to alternate this sign also. Because see, now 2 is bigger. This is a negative something. Negative something. Anything is less than any positive thing. This is a positive number. So this positive number must be bigger than this minus 5. This is the reason why when you multiply by negative sign, you have to actually alternate this sign. And this part is easy actually when you have two things. How can you find out this domain? That means this x plus 3. So this is x plus 3. That means x cannot be equal to minus 3. If it is plus 3, that means it cannot be equal to minus 3. Because if you put minus 3, minus 3 plus 3 equal to 0, and downside we cannot accept 0 because 0 into this whatever it is equal to 0. So we cannot accept minus 3 here. And here what we cannot accept? We cannot accept plus 1 because there is a minus 1. So if you give plus 1, then plus 1 minus 1 equal to 0, 0 into this equal to 0, anything divided by 0 equal to undefined. That means we cannot accept plus 1 and minus 3. That's why we have written it. X, we cannot accept minus 3 and 1, or x is not equals to minus 3 and 1. Now I said that there is a big reason why we have to combine them and what happens when we combine them. Now combine means like this. We can write f of x plus g of x, that means this value, this thing plus this thing. F of x minus g of x, that means this thing minus this thing. Yeah. Then multiply you can do, division you can do. Question is, what will be the domain of this full function? Suppose now we are writing f of x plus g of x. That means this f of x then plus everything here. So it becomes something very big function, right? What will be the domain of that function? Answer is actually simple, and that is answer will be domain of that new function will be the domain of this one and the domain of this one. So domain of their combined individual domain, when we combine, then we will get their domain of the combined function. Now why it is useful? Because sometimes combined function look scary, look big, very big. So instead of finding individual combined functions domain, you can just look at, okay, this combined function came from this function and that function. So what is the domain of this function and what is the domain of this function? If you combine their domain, then you will get the domain of the main big function. And you will see it here. So see, domain of all of them, their domain is here. Their domain is here. Their domain is here. The domain of f plus g, f minus g, f into g, f divided by g, etc. consists of the number that are both in the domain of f and a and the domain of g, both in the this one and this one. If we combine them, then we get the domain of the combined function. This is how we can find out the domain of combined function. Combine means what? Let me show you one more example with the combine. Suppose if I write just a simple example, if we write f of x equals to, we have here, suppose f of x is, then g of x, let's write g of x equals something small, g of x equals to, let's say, we can use this also, but just to reduce the complication, say let's write twice x. So combine means if I write f of x plus g of x, so we will write this plus twice x in that case. In this case we have to write all of them here, then it becomes a combined function. If we write all of them, then f of x plus g of x, then it becomes a combined function. Combined function means we add two functions, divide two functions, multiply two functions, subtract two functions. These are called combined functions. And I think we have done this practice in class practice maths. This is also from the book 63 number. This is actually from a combined function math. This one we have some practice maths from the book 60 to 63. This is actually from next chapter. So please read this one and try to solve this math. These are the practice. These all are practice math. These are not homework. These are your practice. If there is homework, then we will keep it in the Google Classroom. Okay. So I think with this we can just wrap this pre-recorded video. Thank you all. Thank you very much for watching and have a good day.